All right. So, so we're going to solve for x there. How do you solve for x? Do the same thing we've been doing. Cross off the log, base stays the base, other two switch. Same thing yet again. So cross off the log. Base stays the base. Who's the base? The 2. Other two switch. Instead of 2 to the x, it's 2 to the what?
2 to the 4th.
And the x goes over there, right? The x and the 4th switch. And then x is alone, like automatically. What's 2 to the 4th power?
16.
Use your calculator, use by hand, however you want. X is 16. That good? So logs, cross them off. Base stays the base, other two switch. It's the fundamental rule.
Okay.
So log base x. Oh, and the way you say it, you want to speak log. Do you want to speak log? You say log base x of 16 is 4. So the low down number, you say base. That's called the base because it's on the bottom. Log base x of 16 equals 4. So anyway, solve for x. You don't need to say it. I'm not going to give you an oral quiz for the exam. Can you speak this log?
It's a lot easier than I thought it was going
Who's got it? What's the answer?
to be. 2.
Anybody else got that? 2? No? A couple of you? Good. Getting 2, right? Cross off the log. Base stays the base. Who's the base? The x. He's the lower down number. The other two switch. Instead of x to the 16, x to the 4 and 16 goes over there. Good so far? That good? That makes sense? Cross off the log, base stays the base, other two switch. Now, how do you solve that? Well, I would probably just look at it and just go, what to the 4th power is 16?
Look at the last question we just did.
What times itself 4 times? What could I put in here? Times itself 4 times, that would be 16. 2 times 2 times 2 times 2 is 16. X has got to be 2. Done. That's called solving by observation. I just kind of looked at it and thought, 2. Yeah. If you want a more formal method, formally you could do the 4th root. Like that. 4th root of 16. But how do you do the 4th root of 16? You say, what times itself 4 times is 16, which is what I just did right here. It's not really different in the end, right? Right? You break down the 16, you go 4 times 4, 2 times 2, 2 times 2. Remember, the number in the hook is the deal at Target. Christmas shopping is here. It's in force. 4 for 1 deal. There we go. It's 2. So either way, the answer is 2, whichever is easiest for you. Am I confusing you by that? Did you understand that?
Yeah.
That okay? 4th root, right? You break down that 16, 4 2's in, 1 2 out of 4 for 1 deal at Target. All right. Okay. Log base 4 of 16 is x. All right, can you solve for x there? Same thing, cross out the log. Base stays the base, other two switch.
2.
Cross off the log, base stays the base. The 2, instead of 4 to the 16, it's 4 to the x. 16 goes over there. Like that. And then, can you just solve that by observation? What power does x have to be? 4 to what power is 16? Yeah, x got to be 2, huh? 4 squared is 16. Right? Is that good? Is that okay? That seeming weird the way I'm solving that? Is that okay? So just cross off the log, base stays the base, other two switch. All right. Log base 40 of x is 0. See if you can solve for x there. You know what to do, right? Cross off the word log, lose the log, cross it off. And when you cross off the log, when you lose the log, base stays the base, the other two switch. Yeah.
Okay. Oh, wow.
So cross off the word log, base stays the base, other two switch. Instead of 40 to the x is 40 to the 0, x goes over there. Good so far? I'm just doing the same step I do every time so far, right? Cross off the log, base stays the base, other two switch. Now, what is 40 to the 0 power? Yeah, anything 0 power is 1. Remember that? So you do have to remember that at this point. Logs will tax our memory on powers. Anything to the 0 power is 1. So I'll write anything to the 0 power is 1. So you need to remember that. Good. All right. Okay, so number 14. Log base 5 of x is minus 4. Try that one. Lose the log, base stays the base, other two switch. Yet again. So cross off the log. Base stays the base. Other two switch. Instead of 5 to the x, it's 5 to the minus 4, and x goes over there. Is that good so far? Now, what do we do with that? What's 5 to the minus 4 power? What is that?
I have 1 over 625.
Yeah. Did your calculator do that for you? Yeah. So, yeah, some of you guys, your calculators will do it automatically. That's great. If you're not exactly sure, remember, what do negative powers do? They flip things. So really important that you remember two rules. Anything to the 0 power is 1, and anything to a negative number flips it. And then the power becomes positive, right? So this is going to flip it, and then it becomes a positive 4. Everybody good to there? 1 over 5 to the positive 4. And what is 5 to the 4th? Yeah, you should just use calculator. 625. Is that okay? Everybody seen how we do it? So really important that you remember these two rules of powers, because logs will make us remember those. So anything to the 0 power is 1, and negative powers flip things. Remember those two things, and logs won't be a problem. So 0 power, anything to 0 power is 1, and negative powers flip things. Remember. What does a fractional power do? Well, see what you can remember.
Turns it into a brute.
Yeah. Very good. Good job. So cross off that log. Cross off that log. Base stays the base. The other two switch. So cross off the log. Base stays the base. Other two switch. Instead of 8 to the x, it's 8 to the 1/3. X goes over there. Good so far? Now, like what in the world is that? Well, here's the, so there's three rules of powers that you've got to remember. We've had them all, but it's, it's hard to remember everything in math. Anything 0 power is 1. Anything with a negative power flips it and then becomes positive. And then number 3, anything to a fraction, like an a over b. That looks funny. Let me write that a little neater. A over b. Fractional power. Remember, it swings around and becomes a root. Remember, I do the Scooby-Doo thing and like that. Remember, fractional powers become roots. So if you can keep those things straight, logs will be cake for you. I keep adding one to it, huh? few minutes. But if you can keep those 17 things straight, logs, it's just those 3. We are done. I'm not going to add anything more. If you can keep those 3 rules straight, logs are not a problem. But people have a little trouble keeping those straight, so logs can cause trouble. So negative powers flip, fractional powers make roots. The denominator swings into the root. So what? So that 3 swings around and becomes the 3rd root of 8 to the 1.
So x equals 2.
Everybody see that? Everybody see what happened there? To the top, the 8 to the 1, that just stays, just like here. X to the A, X to the A, that hasn't moved anywhere, huh? The top of the fraction in the power stays. It's Scooby-Doo in the bottom that falls through the trapdoor and ends up in the hook. It's the bottom that swings around. So it's the bottom, the 3, that swings around. Okay, so what? Well, then this is just the cube root of 8. 8 to the 1, that's just 8, right? Just a cube root of 8. What's that? We'll break it down. 2 times 4, 2 times 2. There's 3 2's in, 1 2 out. Or your calculator will do it. Most of you. 8 to the 1/3. I'll tell you 2. Is that good? Remember, the number in the hook is the deal at Target, right? 3 for 1 deal. 3 2's for the price of 1. Remember, 3 in, 1 out of the store at Target. This Christmas, 3 2's for the price of 1. All right, so log base 10 of 0.01. Notice something's missing. There's no right side. There's no equal on the right side. There's always 3 parts to every log. There's the base, there's the thing here, and there's the thing out there. I feel like I'm Dr. Seuss. Thing number 1 and thing number 2. So there's the base and then those other 2 things. They've got to be there. So if any of them is missing, call it X. And the last thing is on the other side of the equal sign, right? Basically, you got to have a base. You call it this way. It's a base, it's a plug-in, and it's an answer. It's a base, a plug-in, and an answer is what they're really called. You got to have a base, a plug-in number, and an answer, something it's equal to. Every log really has those 3 things. So if any of them are missing, call them X and find them. So does everybody see what I did? I just wrote equal X, in other words. A fancy way to say right equals X. And then what? What am I going to do? What have I done on every log problem so far? Cross out the log.
So 10 to the x.
Base stays the base. Other 2 switch. 10 to the x, right? These guys switch. 10 to the x is 0.01. Oh, that's not going to be a good way to solve that problem. I mean, it's true, but it's not helpful. Yeah, let me change the plan. I mean, that's true, but that's not going to be an easy way to do it for you. So let's do this. You guys have calculators? Mm-hmm. Got them handy? Mm-hmm. Basically, we're going to do this on our calculator. The higher number goes high. The lower number, lower is the top number goes up to the top, the bottom goes to the bottom. The top to the top, the bottom to the bottom. See what I mean? See how the 10 is lowered down, so he goes to the bottom? Turn it into 2 logs on your calculator. It's dividing. It means dividing of 2 logs. And the answer should be, is it -2? I think it's -2, right? Yeah, -2. See if you can get -2. You get -2 with the top divided by, and the bottom number will come out 1, and so the answer is -2.
So awesome.
So the top number goes top, the bottom number goes bottom. You make it into 2 logs. So make into 2 logs. When they give you log with a number at the base and a number here. When they give you log with a number in the base and a number in the plug-in spot, just make it 2 logs. Are we good there? Does that make sense? So the one that was higher up went to the top. The one that was lower down went to the bottom. Yeah, feel free to check it. Did you remember to close the parentheses on the first log? So when you type it on your calculator, you got to close this parenthesis. before you then go divide by the second one. So type it in like that on your calculator. All right. So yeah, having said that, let me show you a second way to do this problem, because I think both, well, let's just, okay. So log base 10 of 0.001. Try that one in your calculator. I'll wander around for a minute. Let me know if you're having trouble getting that. Feel free to check with your neighbors. Answer should be -3 on this one. -3. Watch it, go ahead. You getting that? -3? So the top one goes top. And there are 2 logs, aren't they? You got to put, notice how we're converting from 1 log to 2. Now, I'm not giving any reasons. We'll do it later, maybe, if we have time. But it's just kind of magic. Poof. Why is that true? Well, it's a deeper reason. We don't have time right now. So that 1 log turns into 2. Does everybody see that? Right, good? And then that comes out -3. So it's how I'm showing you to do these kind of logs. All right. So log base 20 of 1. Try the same thing. The higher one goes, the number on the top goes to the top. Number on the bottom goes to the bottom. Make it 2 logs. So the way to handle these logs is just turn them into 2 logs.
0.
And you should get the answer 0. We good?
Oh, because 22 is 0. Power is 1.
Power needed on a 20 to become 1.
Right.
Good? Now you could do this one by hand also. Let me show you what I mean. You could just put an X over there. That other way I was showing you. You could just put an X over there, cross off the log, base stays the base, other 2 switch, 20 to the X is 1. So 20 to what power is 1? 0. Anything to the 0 power is 1. Of course it's 0. Either way. All right. Log base 5 of 625. Calculator will tell you 4. So make it 2 logs, right? The top one goes top. The bottom one goes bottom. The answer's 4. We good? Can I motor through these? I got 10 minutes. I want to finish this section. We good? I got a problem. So, log base 5 of 125. The top one goes top. The bottom one goes bottom. Make it into 2 logs. Power needed on a 5.
Oh, 2.
So -2. Right. -2? Calculator tell you -2? We good? All right, I'm going to move on. So log base t of t. Now, can't really do it on a calculator. You can't go log a t. You don't have a t. But can you tell me what the answer is? Yeah, because the top goes top, the bottom goes bottom. So what's that? That's 1. Right? Same concept? They're giving us some logs on our calculator here. Do the log, so they just want one log here. Log of minus 34.
Math error.
What's that?
You ever put it over a 1?
Yeah, it's error.
The
You
answer
can't,
does not exist.
no negatives inside a log. Also, no zero. No negatives and no zero inside of a log. If you put zero or negative inside of a log, you get an error. So that means the answer does not exist. Yeah, try log of any negative or even zero. Can't do it. We'll talk about why later. This logs has been a way easier section.
The catch.
It's been one of the easiest things we've done so far. 450 over 60.8. You guys have, I have no idea, it's just some decimal thing. So go ahead and type it on your calculator. I'm thinking the end, I don't even know.
0.693? No, 0.869.
0.8693?
Something like
You guys getting that?
that.
No?
Run to 4.
Is that rounded to 4 places?
Yeah.
Now good? All is well? Rounded to 4 places. No mistakes there. Good. If you have trouble in your calculator, grab me. Just 10, 15 seconds. After class, be glad to help you. Every calculator is a little different. Make sure you can get those. I don't know. All right, so f of x. What's f of x always?
Why?
That's y. So we have y equals log base 4 of x. So there will be one log graph on the next exam. So how do we take that thing and turn it into a graph, a picture? Well, I'm not going to give you anything fancy. You go into higher math, and they give more specifics. But for now, we're just trying to get comfortable with a lot of different. We've done a lot of graphs in this class, haven't we? We've graphed exponentials, lots of linear things, U-shapes, up and down, moved them around. You know, we've done a lot more graphing. We've seen a lot of different graphs. So I'm just going to suggest make an XY table and just plug in some easy numbers and just use your calculator. Just get some decimals, put some dots, 2 or 3 dots down, and you'll be able to tell which answer's right. You know, nothing super fancy here. Just process of elimination, right? Multiple choice. So let's just put in, what's the easiest number you know? 0, followed by 1, followed by 2 would be a great idea. So just put those in, plug them in, use your calculator. So log base 4 of x. So the first one would be log base 4 of 0. Plugging in x to be 0, right? So how do I do log base 4 of 0?
Why would be 1?
So remember, you turn it into 2 logs, huh? So am I making sense on that? So it's just like the other ones we did. The top goes top and the bottom goes bottom. Is that making sense? Maybe we have a few minutes. Maybe I could explain why I'm doing it. I'm trying not to get too deep with you because this is your first exposure to logs. But probably it would help you. Like, you might wonder, why, Mr. Heron, are you going like from 1 log to 2 all of a sudden? Probably worth it for me to explain that for just a minute. When you guys have in your calculator a log button, right? L-O-G. Remember how I said every log really has the 3 parts? You guys tracking with me? Make sure you catch this. This will be helpful to you. Every log really has a base. So there's no such thing as a log without a base. Now, they don't show the base always, but it's got to have a base. So like I could go log base 8 of 15 or whatever, you know, and figure that out on my calculator. But the problem is, look at that button on your calculator. Is everybody looking at that button on the calculator? It doesn't show a base, does it? Do you know what it has? It has an understood base. Its base is 10. Its base is 10. When a log, so when the base is not shown, it is 10. So when the base is not shown, when they write the word log and they don't show the base, it's really got a 10. That's just like if I do a square root of 9 and I don't put anything in the hook. What's really in the hook? 2, right? It's an understood 2. When I write x with no power, what's really on the power? 1, right? We have these various understood numbers that we don't write out all the time. And why? Why don't we write out the 2 in the square root all the time? We write out the cube roots. We write out the other ones. Why do we not put the 2's in there?
Because that unless otherwise stated.
Yeah, because, just like anything else over time, people got tired of doing it. They used the square roots more than any other, and they said, look, if I don't write anything, I mean the 2. We use those so often, just assume I mean 2. Well, the same thing happened with logarithms. I know probably doing logarithms aren't a regular part of your life yet, but that is a regular part of many scientists' lives, and they do so many logs that after a while they said, look, if I don't write any base, it means 10. Just assume I mean 10. In fact, it's even called the common log. It's the one that they use so commonly. Okay, so what? Why am I pointing all that out? Well, that means that's what the button on your calculator does. That button that shows no base, it's really base 10. The button on your calculator is really base 10. So let me write that. Button on calculator is base 10. The button on your calculator is base 10. So so what? Why am I saying all that? Well, then that means if you want to figure out log base 10 of 13 or whatever, just hit log 13 on your calculator. That will be log base 10 of the 13. You with me? So if somebody asks you a base 10 log question, just hit the button on your calculator. That's what it's made for. Great. But what if they ask you a log of a different base? Do you see the problem? What if they say, okay, I want you to tell me the log base 7 of 13 now. I don't want the log base 10 of 13. I don't want that thing your calculator button does, log base 10. I want log base 7. Well, how am we going to do that on our calculator? We don't have a log base 7 button. All we've got is a log base 10 buttons. Everybody hearing me? Is this making sense? Because this will fit it all together and help you really remember why we're doing what we're doing if you get this idea. So again, what logs can you do on your calculator?
Base 10.
Base 10 only, at least directly. We'll do a trick to do the other ones. But at least directly with one button push, all you can do on your calculator for logs is log base 10. That's what that button that doesn't show any base means. If no base is showing, it means 10. So that's great if they ask you for a log base 10 question. Yeah, just hit that one button, you're good. But what if they ask you for a log of a different base? That's where we do the trick. We turn it into 2 logs. When the base isn't 10, you have to turn it into 2 logs. You can't just hit log 13 because it'll assume base 10. So if the base is something other than 13, turn it into 2. So let me write that down. So log base 10 of 13, you would just hit log 13 on your calculator. But if they do log of a base other than 13, like log base A of B, you let the top go top and the bottom go bottom. Is that making sense? So that's the trick. Okay, now I got to finish that graph problem.
Yeah.
That took a little longer than I thought. Let's go back to that graph problem. So we're back on this graph problem. We're putting in 0, 1, and 2. We put in 0, log base 4 of 0. You let the top go top, let the bottom go bottom. Why? Because that log is not base 10.
There's no solution to that.
This one is error. It's a no-go. I'm going to write no there. Meaning the graph is saying, I don't go there. I don't go to x equals 0. That's important because any graph that does, he's the wrong graph. Like, no way to this guy. He's crossing 0. No way. Right? X of 0 is right in the middle. He's crossing the middle. Our graph says, I don't cross with this one. No way. I haven't done anything, but I already know C and D are out. Because this graph just told me at x equals 0, I don't go there. So he's saying, I do. I go there. Well, then you're not my answer. Right? You tracking with me? See how this one doesn't ever quite touch the middle? He just gets really close. See how this one also doesn't quite touch the middle? It's one of those two. I don't know which one now. All I need is one more point. Put in the 1. Log base 4 of 1. Plug in 1 for x. Get log 1 over log 4. And that'll be 0. Over 1, up 0. Which one goes through over 1? Well, they kind of both do, don't they? That one goes through 1, 0. That one goes through 1, 0. Well, I need one more. Do log 2. Log base 4 of 2. Turn it into 2 logs.
1/2.
Thank you. 1/2. Over 2, up a half. It's this one. See, that one's going up after 2? We got it. Does that make sense? Just do a couple dots so you can tell which one it is. Process of elimination.